So yesterday we talked about angles. Shh.
Angles.
Okay, where was 0 degrees on the XY coordinate?
On the right.
Okay, which made this
90.
90.
180. 270.
Why don't you make the assignment symbol?
You're doing this sophomore a disservice here.
Yep.
Think of it's Corey's birthday. You're gonna give her an assignment.
Is it really?
Yeah, it is.
Happy birthday, Corey.
Happy birthday,
Shout out Corey.
Corey.
Happy birthday.
Happy birthday.
Mr. Jordan's present is a mean assignment.
Yep. Enjoy your birthday present.
That's unfortunate.
Okay, so today we're doing something called radians, which is another way to measure angles instead of degrees. So in degrees, a full revolution is 360 degrees. Actually, in radians, let's talk about this. Let's put it over here. 180 degrees in radians is worth pi radians.
What? Oh, is it like circumference stuff? Because it's like a round circle.
Well, okay. I think the reason they made this up is because of the arc length formula. It makes the formula really easy when you measure like this. So instead of calling like a half turn 180 degrees, you can also call it pi radians. There is no symbol for radians. Like degrees has a little symbol, like a little circle up there. You can tell it's radians because they either there's like a pi in it, or they might say the word radians. But so pi radians, what that means is it's about 3.14 radians. Okay. Usually the radians are written in with pi in it, but you can write them in decimal form too. But this is neater than this, and also this is like rounded off. So this is worth pi radians. So this is worth 0 radians, or guess what this would be?
0 pi. Just
Okay, if this is worth pi, 1 pi, what would this be worth? 2 pi. So 360 degrees is also worth 2 times pi. Okay, if this is pi radians, what would this be worth? Or sorry, this is pi. 1/2 pi. The books like to write it like this, pi over 2. But it is 1/2 pi. Okay, and for 270, this is the trickiest one.
3 is over 4 pi.
Negative
Close.
half pi.
Okay, this is 1 pi, so 3/4 pi would actually be like right here. So it's 1/2 pi, or the way the book likes to write it is 3/2 pi, or 3 pi over 2. So maybe we should talk about that for a second. So 3/2 pi is the same thing as 3/2 times pi over 1, right? Which is the same thing as 3 pi over 2. So if you put the pi out of the side of the fraction, it's like floating in the middle. If you put it in the fraction, though, it goes on top. These are the same thing. Okay. I feel like I'm forgetting. Oh yeah, I remember. Okay.
60 is 2 pi.
So there's a lot more angles, of course. Like remember yesterday we talked about this being 45 degrees. Shh. This is 45 degrees. This is also like 1/4 of this, so it's like pi over 4. Okay, a lot of these are written in your book on the top right of page 453. They've kind of got a quick reference picture of a lot of these angles. You guys see where I'm talking about? That circle. So, like at the top it says 90 pi over 2. So that's helpful for some quick reference. Now it does, of course, doesn't have all the angles in it. Because there's infinite angles, but so here are the converters that work. So why don't you guys give me an angle and we'll convert it.
45.
28.
Okay, we'll do 45. That's fine.
Yes, I'm winning.
28. You're too late. All right. So the converter, if we multiply this value by 1, it keeps the same value, right? So what you want to do is multiply by pi over 180. This converts from degrees to radians. Okay, you just multiply by pi over 180. What ends up happening is, if you have a decent calculator, the pi is not really going to stop. The pi is not going to really do anything. The 45 over 180 will reduce, and you'll get like that. Your calculator might say 1/4 pi, which is fine, but yeah. Okay? So this is the degrees to radians converter. You might remember it because you want to like multiply the pi in, like to turn it into radians, so the pi goes on top. Okay, there's also a radians to degrees converter, and it's almost the exact same thing. So, shh, hush. Okay, so let's say we had like 8 pi, and I want, what's that in degrees? You would multiply by 180 over pi. So when you're trying to convert it into degrees, you want to get rid of, like the pi's would like cancel out, because that's like the radian part. So you want pi in the denominator. But this is the magic thing right here. Okay, however,
This is taking a while.
however, there is a trick for these. You don't have to use this. Pi, basically, if there's a pi in the radians, you can just turn that into 180. So 8 pi equals 8 times 180 degrees. Okay, you can use this. If they don't have the pi symbol, you have to use this. But if they do have the pi symbol, you can just change it into 180 degrees.
I used to just times it by like the number times 180.
Mm-hmm.
Why?
Pi radians is worth 180 degrees. So you can like swap them out.
I'll just stick
Right.
Okay, this also works. It just is
But
more.
You do that when you do or don't have the pi symbol.
Okay, so if they said it's like 7.2 radians, which I don't believe they're going to do on this assignment, there's no pi to turn into anything. So you would just have to do 7.2 times 180 over
Okay.
pi. And just, whatever that is.
But if they both have pi, you can.
On this assignment, maybe this whole chapter, I think that on the radians, you're always going to see a pi.
Okay.
So you can use the easier trick and just turn pi into 180.
I see. It makes sense.
Yeah, basically what this converter does is it just cancels the pi's out.
So you can just cancel them out pretty
And
naturally.
yeah, basically it turns the pi into a 180. Okay, anyways, number 1. So we want to turn pi over 3 into degrees. So just like I talked about, that's the same thing as 180 degrees divided by 3.
Mm-hmm.
Also, the answer to number 1 is in the picture, if you look at that green line. But not all answers are in that picture, so it's good to be able to know how to do it. I think this is the marker that makes that noise. I think if I just hold it at the right angle, like my artwork. I call this Skylar.
Actually, no. This is a big blob.
Exactly, exactly. She gets it.
Look, she drew ice cream because she was so hungry. Yeah, you little.
By the way, Skylar, somebody gave Issa a Pop-Tart, and I think it was supposed to go to you.
Roman gave it.
Skylar was walking out, and Skylar goes, "Hey, what you got there?" And she goes, "It's mine."
And well, okay, but then the thing is,
Lisa, is that gonna find its way to Skylar? She's like, no. Okay, anyways, so what do we do on this one?
Divide 180 by 5.
180 divided by 5. Like 36.
I'm so sorry for that.
You're all fake. Y'all are fake. Everyone's fake. Everyone's fake doing that.
Okay, number 5. So the degrees to radians, it doesn't have as easy of a trick, but you want to multiply in the radians, right? So that's why pi goes on the top. So it would look like this. You can plug that in your calculator. Okay, stop.
Stop.
Okay. This is going to reduce to 12, so it's pi over 12. Your calculator would probably say 1/12 pi,
Low-key like that.
which is fine.
Does it get harder once we get to 9?
Nah, it's not too bad. I mean, it's more work than this, but it's not bad. Anything is more work than this. Okay, same thing on number 7. It's going to multiply by pi over 180. This one doesn't reduce as much. In your calculator, you could just plug in 175 over 180, because that's basically what happens. And then just put pi in your answer.
You know what, Mr. Jordan? Now that you say that, I would have been fine with Lisa taking the Pop Tart, but she was rude about it. She was rude about it. She didn't just say, "Oh no,
Skylar's
don't
not
eat
rude.
it."
She goes,
It's
"It's
mine. No, it wasn't, you rat.
She's like Gollum.
It's just a good
Oh, here's
little
pi. I found it.
Right,
You found
precious.
pi, Whitley.
Wait, so how was it supposed to be mine? I'm confused.
Roman gave her to give you.
Why did Roman give you a Pop-Tart?
Oh, because there's context. In history one time I stole this Pop Tart for $5. I didn't steal it.
If you stole them, why would he give? Okay.
I
All right. Number 9. Draw the standard position angle with the given measure and state the measure of its reference angle in radians and degrees. Okay. In other words, we're going to draw the angle and then state the reference angle in radians and degrees. Remember, reference angles just means how far is it from the x-axis.
It's 60.
Okay. Yeah. Pi over 3. You could kind of cheat and look at the picture. Pi over 3, we did this on number 1. That's just 60 degrees. And where is 60 degrees at?
Before 90.
Yeah. It's like 2/3 of the way to 90. Maybe too steep.
That wasn't too steep.
Alright, we'll say that's pretty good. Alright, anyway, from there to there, that's pi over 3. What is the reference angle?
60.
How far is it from the x-axis?
66.
Pi over 3, which is also 60 degrees. We have to say both of these.
What?
We have to say the radians and the degrees for the reference angle.
horrendous. But if that's why, if we know,
It's just another way of measuring angles, radians. And I think they invented it because it makes the formula on number 15 really simple. Alright, number 11. No, wrong one. Negative 3 pi over 2.
240.
Okay, if you convert this, actually 3 pi over 2, positive 3 pi over 2 is in the picture.
Yeah,
Oh,
so
I was looking at 10. My bad.
It's 270 in the picture. So this would be like negative 270. So where would negative 270 go? 90. Yeah, it goes to positive 90, but it goes backwards, so it looks like that. So, okay, what is the reference angle?
90.
Yes, how far is it from the x-axis? 90 degrees, or what's 90 degrees in radians?
Pi over 2.
Yes. One way, so remember this is pi radians. Remember yesterday we did 180 minus the angle to find the reference angle. You could do, well, I guess this would be negative pi. You could do 3 pi over 2 minus pi. to find the reference angle. Anyway, it's pi over 2 or 90 degrees. Reference angles are never negative. It's just how far is the angle from the x-axis. Okay, 13, 5 pi over 4. Is that in the picture?
Yeah, 225.
Okay, so where's 225 at? It's like halfway between there and there.
So then would you subtract that by pi?
Right, exactly. So you could do 5 pi over 4 minus pi to figure out how far that is. Pi is like, yeah.
Pi is 180 basically.
Pi is like 1 pi over 1, which is like 4 pi over 4. So if you subtract it, you get 1 pi over 4, or just pi over 4. Anyways, that's the reference angle. Pi over 4, or how many degrees is it? 45 degrees. Okay, I think the last we're in the last section, right? Yep. All right. Do you guys remember arcs from geometry?
No.
Sometime ago.
Yes.
I got too big. I lost my gift.
We're looking.
I mean, it's kind of there.
Deformed.
I call this Skylar.
Oh, in that case, it's perfect.
You can't take back what you said.
No take backs.
Stop.
You didn't even grab it with your little slimy hands.
You
Two
two
braggy
braggy little hands. If it was not scoot code.
Okay, you guys remember what an arc was?
Whitley doesn't.
Oh, it's like the gap between the two lines.
Okay, it's a
Me neither.
piece of the circle. So you guys might remember there's like an arc symbol. We're not really messing with that today, but so this would be a radius, right? R. This would be called a central angle, theta. So for some reason they use S to stand for arc length. Stop. Some reason they use S to stand for arc length. I don't know why, but if we were doing the arc length and we were using degrees for this central angle,
It's over 360.
the formula would be, it's basically the circumference times theta over 360. However, if we use radians,
Oh, I remember this.
it's the circumference times theta over 2 pi, but what happens is 2 pi cancels out, and arc length is just the radius times the angle. This is why I believe, I'm guessing, this is why they made up radians, so you get this tiny little formula.
So then basically all we'll be doing is x equals pi times theta.
Right. If you have radians right here. If you have degrees, you're gonna have to fix it and make it radians. But yeah, basically, it's pretty easy. But this is the formula we're using. Arc length equals radius times the central angle, the radians. Okay, so on number 15, we're finding the missing variable. On 15, they tell us the radius is 5. They tell us theta is 2 pi over 3, which is definitely radians. So all we have to do is multiply those together. Now, hush. That would be like 10 pi over 3, but the directions say round to the nearest tenth place, so guess what? We need the decimal form. So hit your decimal button on the calculator, and this comes out to 10.5. Darn it.
When you take off, you forget to label.
I didn't label in the other class. All right, number 17. This time we know theta and s, the arc length, but we don't know the radius. So s is 3 pi. Theta is 6 pi over 7. But we don't know the radius. So how are we going to solve this for r?
3 pi divided by 6 pi over 7.
Divided by 6 pi over 7. So in your calculator, you could plug in 3 pi like this, divided by 6 pi over 7.
Okay.
That'd be the easiest. I mean, plugging this in would be a lot of button presses.
Okay.
So I would just plug that in. The division button instead of the division bar. Yeah, all that happens is this kind of reduces, and it's 7 over 2, which is like 3.5.
Just.
Unlike normal, we are not going to leave it as a fraction because the directions said round to the 10th place. Okay, 19, they give us the radius and theta, just like 15, but this time theta is 15 degrees.
And you just make it differently.
Yeah, we're just going to turn it into radians so we can use that formula.
Pi over 8. Is that what it is?
I feel like we already did 15 degrees, didn't we?
No. I'm guessing. Pi over 8.
Pi over 180, is that what you mean?
No, but like is the answer pi over 8?
Oh, well, even if it was, yeah, I think we did.
Oh yeah, we did.
I think we did do 15 because I remember this. Pi over 12 is what it would be in radians.
Mm-hmm.
So we're going to use this instead. So the arc length is 35 times pi over 12.
36.
Or 36?
Yeah.
Which is about
3 pi 9.4.
For some reason my decimals look like little hearts. That was not intentional.
It's cute though. Aww. It's because you love our class so
It's
much.
so demure.
That is not to me.
You're just upset you drew you earlier.
Deformed.
According to you, it's deformed.
You're all